Strength of acids and bases. We know that some acids and some bases are corrosive, therefore they are dangerous and must be handled with care. But on the other hand, there are acids and bases that are perfectly fine and even found in the food we eat or use in our daily routines. So it's obvious that some acids and some bases are stronger than others. So what is responsible for the strength of an acid or a base? Well, the strength of an acid or base depends on how many acid or base particles dissociate into ions when put in water. When a strong acid dissolves in water, nearly all the acid molecules dissociate into ions. These would be acids such as hydrochloric acid and sulfuric acid, like what is found in car batteries. This is the same for a base. When a strong base dissolves in water, it will dissociate completely to produce ions. Now, when a weak acid dissolves in water, only a small fraction of the molecules dissolve in water, such as acetic acid in vinegar and carbonic acid in soda. Again, the weak base follows suit and does not dissociate completely when in solution, just like a weak acid. Sometimes when referring to acids and bases, many times the terms strength and weakness get confused with concentration. The terms strong and weak are used to classify acids and bases. We just learned that strong acids and strong bases dissociate completely in solution, where just like weak acids and bases only partially dissociate in solution. Now, if we remember the terms dilute and concentrated, these are used to indicate the concentration of a solution, which is the amount of an acid or base dissolved in a solution. So it is possible to have a dilute solution of strong acids and bases, just as it's possible to have a concentrated solution of weak acids and bases. When we need to measure the concentration of something, we sometimes use what is called the pH scale. And the pH of a solution is the measure of the concentration of H plus or hydronium ions it's in. The greater the H plus concentration, the lower the pH is, and the more acidic the solution is. The pH will measure how acidic or basic a solution is. The pH scale ranges from 0 to 14, and as you can see on the scale shown here, that solutions with a pH lower than 7 are acidic, and the pHs that are greater than 7 are basic. The other thing you will notice on this pH scale is that the lower the value is, the more acidic the solution is. And the higher the pH, above 7, the more basic the solution is. Now, if a solution has a pH of exactly 7, this indicates that it is neutral, meaning that the concentrations of H plus ions and OH negative ions are equal. This would be a neutral solution, such as pure water. Many times to determine pH in lab, you will use a universal indicator, which is a paper that undergoes a chemical change in the presence of hydroxide or hydronium ions in solution. Now, the final color of pH paper is matched with colors on a color chart, which you noticed a few images back. There are other more accurate ways to determine pH as well, such as pH meters, which give very precise readings. So looking at the scale, if I were to tell you that baking soda had a pH of 9, would you consider it an acid or a base? Okay. How about this? Would it be considered weak or strong? Correct. You guys are great. It would be a weak base. How about if I told you hydrochloric acid has a pH of 1? Would you consider a strong or weak acid? Correct, strong. The further away from neutral, the stronger the acid. All right, I think you guys are getting the hang of this, and it is time to show what you know.